To look at this of the linear regression, how to implement this of the linear regression. The implementation is basically simple because this is a linear program and one of the basic models are there, and also we're also able to learn how to actually evaluate them, to actually know how well your model was actually performing. We're able to get these outputs here. This is the first was actually what we predicted, second was actually mean squared error, mean absolute error, and that of the how to score. So these are actually things we're able to cover in our video and a video before that. So what I'm basically going to look at in this video is actually that of the logistic regression. When we look at this logistic regression, you can see the name regression, but don't get it fooled. Don't get yourself fooled by this or confused by this model. This model is actually a classification model, not a linear model that actually solve that of the linear model. When you come to that of the linear and that of the classification, or can say regression and that of the classification based model, these two guys predict based on different stuff. Because when you look at this linear tend to predict a kind of a continuous data. Meanwhile, most of the time the target values are always high. When I mean high, they are continuous values. They are not actually kind of discrete. Maybe they are assigned to maybe 0 and 1 to that of the on and off, for those kind of discrete type of values. So doesn't mean you can actually use classification for linear and linear for classification, but it's not actually that quite advisable, if I might say. So that actually says it much. So that's why we're going to make use of that of the classification and that of the logistic regression, and that of the logistic regression fall under that of the classification based model. So and it belongs to that of the linear model, even though it's actually that of the classification based model. So let's actually go up and import it. Then I'm going to dive into explain things you should know about this of the logistic regression, how the logistic regression, the way it makes its decisions to actually give us output. So remember, it's other part of this of linear model, so we can actually call that logistic. I think that should be logistic regression. Yeah. Thank you, VS Code, for helping me to print it, as I don't need to type it from my fresh here. What is this? The logistic regression, we have actually imported it. So how does this logistic regression actually work? So let's actually head over to my WordPad so I can use that to actually explain. So I'm going to go to Paint. Let me actually extend this guy more. So when it comes to that of the logistic regression tend to make use of, I can say, two formulas. One is for the other stuff concerning that of the to finding the base parameter and other understanding our model, and the other one is for the output. The output of the many classification based model, or most of the classification based model, are making use of that of the sigmoid function to actually turn it to maybe 1 or 0, or maybe to classify them, making use of that of the threshold. So let's assume that when I'm talking about the threshold is more like what percentage will this predict, what percentage will you predict something that you can actually say that okay, this is going to happen, this is not going to happen. Let's assume that you predicted that rain is going to fall, but how sure are you? Let's say I ask you how sure are you? You assume that you are 60%. When it comes to that of sigmoid, or most of the classification based model, when the threshold is above 50% or maybe 50% and above, it classifies them as maybe 1, depending on the discrete value that you set it, or on your data that you actually set it. You can classify them as 1. And if it's below that, you can classify them as 0. So that's actually, if you have multiple values for that of the target, it's going to give each of them the probability of each of them, and then they're going to make use of the highest, going to use that of the mode to actually get the output. But let's actually look at some of the formulas that this of the logistic regression actually use. There are a whole lot of them, but these are the ones that I can actually remember. For that of the sigmoid, let's actually say this is the sigmoid function. The sigmoid will have that of the 1 plus this of the, remember that this is actually plus e minus z. Why this is just the constant, is actually constant 1 divided by 1 plus e exponential z. So this is where the magic actually happen. What have I even done? This is actually where the magic actually happen on this of the z. We have that the z to be that of the, we have that of the weight, you can say with 1, and we have that of the our x. Let's assume this is our x1. Then we have, let's assume we have another with 2. I'm going to explain what I'm actually writing here. I'll have this of our x2, and then we'll have something maybe dot dot, maybe something like dash dash dash, maybe something like w z and that of xz, and then we'll at the end we'll have something like b. What does this guy that we actually have here, what does this actually signify? This W that we have here, this W stands for the weight. The formula to get this weight is actually available, but I can't actually remember the formula to actually get the weight that is going to be assigned for, you can say, each of the, for the get multiplied by that of the weight, by that of the future. So we have this of the x to be your input future. This is futures. The futures, you are going to be the one to actually send out of the futures. So the logistic regression is not going to actually do that of the future. So this x is that of the future, and this of the b that we have here, this is b, is the bias. That should be bias. This is going to be a bias variable, and this of the weight is going to be the weight that is going to be assigned to the model. And then for this of the z to be gotten, so remember that I said that this z is where the magic happens. This actually finds the weight by making use of that of your future, the input stuff that you actually set it to find the weight, and that of the bias with your futures is going to multiply everything, and then it's going to add it to that of the b, and then it's going to get your z. So let's assume in a case whereby our bias may be something like let's assume we have something like 5, and then the weight was set to maybe something like 2, so it's going to do for that of the feature 1, feature 2, feature 3, and then to maybe the amount of feature you give it there, it's going to add this weight to that of the feature. Let's assume your feature may be something else, it's just going to do 2 times that of your feature, this x inside your feature. Remember, this is why, this is one of the reasons why I actually said this x. So when we are looking at the example, so it actually tend to make sense a little bit. So when I mean S, I'm talking about the features that were set in there. This of the S. Remember that this is our feature. This is actually for linear regression. We have not started our implementing of our logistic regression. So this is the weight, and this is the bias is going to be added at the end. The weight is going to be found by that of the logistic regression, and is going to actually add it, and then going to calculate it to get our z. When you get our z, it's going to turn into that of sigmoid function. The maximum value of this or the sigmoid function, remember that sigmoid function turns it to that of the, let's say, the percentage or the probability. And I mean that the maximum is going to be that of the 1. Let's assume we have something like this one here, actually, as if you are looking at 100. Let's actually we have something like, when do I have something like, maybe this is actually 1, and after we are done adding these together, we have something like maybe something like 50. When we do 1 divided by 50, automatically is going to, let me open my calculator, automatically it should give you maybe 0.5, if I'm not mistaken. Why do I have this? Let's actually do that. So let's assume we have something like 1 divided by 50, and then we're going to have 0.02. So let's assume we have something like maybe 1 divided by, let's say, 10. And so we have 0.1. So if you times 0.1, automatically it should give you, okay, that should be times 100. Let's say 0.1 times 100, we're going to get 10%. You can see that when you times it by percent, like I can see we've times it by that of the 100, which is the rest of the percentage, we got 10%. So I know that at the end of the day, you are still going to get the higher the value, I think that's the lower the, let's assume here was 500, so we had maybe let's actually do for 800, that's in 0 point. So let's assume we have something like 1 divided by 1 So we have 1 times. That's going to be, I can say, a model that predicted 100% for the data, which I know most model can even get to 100%. I think for this to actually reach this kind of percentage, maybe I'm suffering from overfitting from the model. So I see that the help of this sigmoid function. What the sigmoid function is actually to help you suppress that of the, as I can say, to convert your output to that of the probability of for that of the percentage to be easier for you to actually understand the data really, how well your model perform really well. So I think with this few of the stuff or the maths that I don't want to actually make this maths more complex the way it already is. There's other mathematical aspect that comes with this of the logistic regression. The higher we go with this of some of all this model, the more complex the maths actually become. But let's actually see how we can actually implement this of the logistic regression. Remember the first thing, I've actually imported the logistic regression. So let's actually, which data can we actually make use of? Should we make use of this of the gender, age, salary, color, and that of the experience? Our target can be this of the gender, even though not. Let's not try make use of. Remember that on a real data, we are not going to make use of on a real life scenario. When we do this, when we actually start to implement, when we actually try to solve a real life problem, we're not going to be dealing with this small data. So, but the ideology that apply on this small data also apply on those of the big data. There's not actually other things. Since once I've been following on our tutorial on how to actually make use of all these simple imputer, KN imputer, MIMAS, robot scale, and a whole lot of that. But let's actually implement these as we go. I'm going to explain more. I have the data we are basically going to use, which is actually this of the age, salary, and the purchase. Our target is going to be this of the. So what have I done? Our target is going to be this of the purchase. This is actually a discrete value, and this is actually the best for that of the classification problem. Since logistic regression is a classification problem. So we're still going to pass in the value that we. What is this? Why did I have 2 data here? So let me just get rid of this. I think that that was one of the things we actually did in our linear regression. So now we are going to make use of that of the logistic regression. Now when we look at this salary and the age are now going to be our features. So we are going to, let me just copy this. I'm just going to put it here. This is going to be the first, and then the second is going to be this of the salary. So they are not going to be our input feature. Remember, it's going to be 2D array. If you don't actually say 2D array, don't worry, the array that you are going to get will explain what you should actually do. So let's actually do this for this our data and the predicted. What do we actually want to predict? We're still going to predict our. This is actually the predict. This predict DF is going to hold that data that I want to actually predict. So I want us to actually still predict this data that we're actually passing. So it's still going to be. Let's actually this predict DF. What are we going to set for? It's going to be this of the same age, and this of the. So it's going to be data. It's going to be. Let's actually just set it. Let's not make things even more complex. So for this of the, okay, let me just copy it. What am I doing? Copy, paste, and for the second one, we can actually copy that of the salary. They are just basically the same thing. Or rather, we can just actually make use of that of the we can actually pass in that of the x. So there's something I want us to make use of, which we didn't actually use in our linear regression, which is actually that of the train test split. That we can actually make it, which is actually to split that. The reason why I didn't make use of it earlier because our data is really small. So trying to split your data where your data is really small is actually a bad idea. But I think it's actually a good idea for us to actually understand on how to start getting that of the can say getting used to it on how you can actually use it. So I think we had this somewhere here. So it's going to, that is actually train test split. I've imported it earlier. So if you are this part of that or the model selection, so if you have not checked my video on that, make sure to do that. So I use this somewhere. I don't want to start afresh to write it again. So we actually use it when we actually talk on how it can actually be used. So let me actually just paste it here. Yep, I think this is actually set to this. So I'm going to explain what actually let me get rid of this. So remember that the x value that we're trying to actually pass in for this of our input future is going to be for that of the age and that of this salary, and our targets will be this of the purchased. I don't know why I still said this salary here. It's going to be the purchase, which is actually how that of the discrete values of 0 and 1. So, and that we created a variable which is the S train, S test, Y train, Y test. I explained this to you guys really well. And I think that was the 3 videos before this talking about that of how to make use of this train test split that exists on this of the Scikit-Learn. So this is the S, the input feature. This is our target, and then this test side. How many of our data do we want to actually use for our testing purpose? We want to actually make use of 20%, because if you times 0.2 times 100, we are going to get out of so we are going to get out of 20%. And this of the random state, we actually set it to maybe an abstract value, which is 42. You can actually set it to any one of your choice. So, and then we are going to declare our logistic regression. I think that should be logistic regression. I remember that for this of our linear regression that we actually made use of it, the other parameter you can actually set to actually make your linear regression to actually perform well, which we didn't actually do in our previous video because the video was actually getting too long. So for this our logistic regression, the actual other parameter you can actually set to actually make your logistic regression to actually predict maybe you can actually learn more on that of your data. So actually, I hope that actually was enough to actually explain it. So logistic regression, you can actually set the parameter, a whole lot of them. If I hover over there, you can see that the penalty, the dual, the tolerance, the intercept scaling. I think that, okay, sorry, there's not even actually it. We have this of the mass iteration. The default is that of the 100, the multi-class. We have the auto over multi Numia automatically set to that of the auto, and that of the end job is actually that of the int. Default is actually that of the none. So the whole lot of other things relating to this of the logistic regression, specify number penalty, blah blah blah. The whole lot of them. Just by if you are using VS Code, you can just move your cursor on top of it, and then it should prompt you with some of all these things. You can actually read about logistic regression and how to actually make use of this logistic regression. So I think with this right now we've actually set everything we want to actually do. So this is actually our target. Sorry, this is our futures and this is our target. We actually splitted our data to that of the for that of the training and for that of the testing. So note for the training, for the fitting, whereas actually for the training. So here is going to be for that of our training, our S training and that of the Y training. Actually for training, because that's actually what we are going to use to train the model. So what are we going to predict? We are going to predict our X test. Our S test, what is actually our S test? Our S test is the actual data that we actually reserve that we want to actually use to test how well our model was actually performing. So remember, I explained all these guys really well in our previous video. So yeah, in our video we want to talk about the train test split, explain what is S train, Y train. I can actually give it any name of your choice, S test, but most of the times it's actually good if you give it one of the most used names out there, because when you start working with maybe outside of your school, like I explained some video before this video, and this logistic regression is actually a classification based model. So we are going to train it with this of our S train, because our S train and that of the Y train is going to have more of the data, because S test we always set it to use 20% of our data, and the S train is going to make use of that of the 80% of our data. So our model is going to learn from that of the 80% of data that we actually give it. This is of the S train and that of the Y train. I think this actually makes sense. And this of the model that predict, we are trying to predict the X test. X test is going to be what I mean by it is going to be the reserve that the model have not actually seen this data, because what the model actually saw was this of the S train and this of the train data. That's what the model have actually seen. So these X tests have not. So it's going to try to predict this of the X test. So we are going to see the results. So let me just actually get rid of this. So the S test is going to actually be predicted. It's going to get the values that what is actually what is predicted. Let's assume that the S test was just this 45 and this 6,000. So it's going to predict whether if it's 1 or if it's 0. Then after that, we are going to actually draw the graph to actually see the predicted and actually the real value that we actually set it. Remember that I silenced this mean squared error and then mean average error, and that R2 score we actually looked on that of a linear regression. That linear regression, for linear models, we actually use this to evaluate it, but for that of the classification models, would actually make use of these guys to actually evaluate how well our model is. We make use of that of the accuracy score, that of the confusion matrix, and a whole lot of stuff. So when we look at it, we predicted 0 and 1, but this is actually output that this is actually trying to tell us that the S test or the value that for this of the X test is actually that of only 2 rows that actually exists on this of our S test. So we can actually print our S test and also add that of the Y predict. So let's actually do that. I don't want us to turn it to a data frame, so we'll make things not really confusing. So let's actually print this of our S test that we have. So let's actually see what was being passed into our S test. Let's actually run this, and then we're going to compare it to the actual value that we actually move over here. So it's going to give us the particular age, the particular salary, and then what it actually predicted for this of the purchase. So remember that you can actually actually give you that of the S train, but the S train, the model have actually seen that of the S train. So giving it that of the S train, it doesn't make sense any longer. So when we look at this, we see that the age, the value that is trying to predict, that the model have not seen that was being sent was this of the 22 for the age, which was this girl, and then the salary was 20,000. So what did he actually predict? He predicted 0. So when we look at 20,000 and it was 0, the model actually predicted it correctly. You can see that logistic regression predicted this correctly. And the next one was this of the 4,005. Now the initial one was 1. Actually what we actually said was 1, and it predicted 1 correctly. You can see that linear regression. So why did I mistake linear regression to logistic regression? This logistic regression was actually able to predict this of our data very well. So let's assume that we actually gave it a new data to actually predict. Let's assume remember that this S test is not going to value any longer. So let's give it new age. So as me, we gave it new age. Remember the age, was actually that of the 23, and then maybe the salary was actually maybe something like 90. Okay, let's say 120, 1, 2, 3. Remember that this signifies the first. You can say the first feature, which is this of the age. Second is the second feature, which is this of the salary. I explained all these guys in our linear regression. Remember, you have to be inside this of the 2 dimensions. So but we're still going to get kind of output, maybe a kind of a warning. This is trying to tell us that when we pass this of the S for the training, we actually give it that of the future name, but when for the prediction we did actually set that of the future, but it doesn't really matter. Let's actually run that and see what we actually got. Then after that, we can try to actually move in the entire data that the model have actually seen plus new data. We can actually draw graph to actually see. Okay, maybe we can actually just set the X test. We can actually give, since we already know that the S test was actually able to the model was actually able to predict that of the S test really well, that we can see here. So drawing graph for it is no longer any use. But let's say in a situation whereby we have the data is really huge, it's definitely not going to predict everything correctly. It's going to predict some well, some is not going to be well. So you can see that this new data that we sent it, this is the warning that we actually got. S does not have valid feature name, because when we actually went for that of the training, we said that of the training, which was this guy training, we actually passed this or the feature name, because Scikit-Learn works well with pandas. If it doesn't work well, you don't need to, you can't pass this feature names on it. So because it works well, that's why I was able to pass it, and I don't want to make use of those consider to all the values like I explained that of the linear regression. So hope I'm not mistaken linear to logistic regression. So see, this is the age is 23 and the salary is 120, the predicted one. So I think that's actually makes sense. So let's actually look at the threshold that this logistic regression actually gave, because right now we don't actually know how well we can say how did he actually okay, what I mean by the threshold, that like how I explained this, or the sigmoid actually turn into that of the probability. So to do that, logistic regression tend to have these. So let's actually print it. It's actually called that of the model dot predict underscore, I think that should be underscore proba, and they are going to give it what we actually, which in our case is, let's actually pass it that of the S test. Remember here we predicted that of the S test, but let me just set this of the X test here. So that should be S test. So we predicted that of the S test. This is actually the prediction. They want to actually see the threshold of the what I mean by threshold, I mean how each the zero and that of the one, what probability did he give each of them before I actually use the highest? So which one was actually the highest? But if we see this, we can actually understand it a little more. So when we look at this, what is this? Rather, this guy, you can see that for this 0, he actually gave it almost 100. Why am I having this kind of output? Here was 1. Here was this is the output that we got. This is not the type of output that I was expecting, but this explains to us why we're able to get this 0 and 1. Because when we look at this, we have that this 1.000 plus 0 I'll have this of the 4.389 exponential minus 13. I see that this is almost turned into that of 0. I can see this is actually 0 automatically. So this should be, when we try to get this output, or can say the mode of these two elements that exist here, we know that this is definitely for that of the 0 colon, and this is for that of the 1 colon. So in case if you are confused, the lowest start from that of the lowest to that of the one. Let's say now target was like maybe something like 0, 1, 2. So the first is going to be for that of 0, second is going to be for that of the 1, and then 2 is going to be for that of the second color, I can say 2. So when we look at it, you see that this guy is almost 0.00 and this is almost 1 point. This is more like 100%, like how we actually see here. That's where we're able to get 1%. So you can see that from the look of this, our model tend to be performing a little bit well. But let's actually see this guy. We know that this guy should be approximately 100% or that of the 99%. So this is actually to go to, if I set that of the 0, it's going to target this particular element, and then the 0 again is going to have this element. So as I actually said, that this is going to be 0. There's a better way to actually do. Let me just make it simpler, 0. So let's actually want to actually target for this guy. Let's actually see what we actually, we know that these guys are automatically 0 from the look of it. But in case if we actually want to do this, let's actually just set it in a variable. Can actually call it our pred. Let me just say this, move this inside here. So we're going to have our press for that of the 0. Then we can actually make use of the press to actually get the for this of the other one, which is going to be 0 and 1. So let's actually do for the other ones there. I can actually make use of that of list comprehension or other stuff. So here is going to be for that of the second element, which is going to be here, is that particularly that in that of the index 1. So here is going to be index 1. This particular list automatically is index 1, and then colon 1, which is actually where it falls on. So let's actually get this to actually visually see the output. So when we look at it, you see that we get this for the first one, we get 0.9, and that's almost 99.9999%. And this other one 4.37 exponential. Remember that, make sure you look at the last digit. So exponential minus 13. This is actually tending, money is actually tending to 0. This is almost like 0. And then we have the other one automatically 0 point. And then this, remember that this 0 and this of the 0.9 are for that of the, you can say, for that of the target of target name feature, which is for that of the 0, not target feature, but the target variable, that the way is arranged, like I explained. This colon is for that of the 0, and this other guy is for that of the 1. You can see that this is actually 100%. This is that of the sigmoid function. When you look at that sigmoid function, it's more like what we actually have here is more like 1 divided by 1. That's actually where we're able to get that. This was able to get this 100% accuracy. So the next video, this actually explains a whole lot of things in this of the logistic regression. Like I said, the other parameter you can actually set on this of the logistic regression right here. So remember, this is a recap of everything that we did. We created the data that we used was just a simple data with this of the age, salary, and that's of the purchase. The data doesn't really actually have any meaning, and they don't actually have anything mapped to actually them. So we have the 18, we have the age and the salary as the input feature as that of our X, which is actually here. Our target was this of the purchase. This is actually for our target, which is our Y, you can see our Y colon. And then we splitted data to that of the training and for that of the testing, setting that of the test side to be that of 0.2. After adding that of random state, so anytime I run this, we're still going to get the same result. We have this of the logistic regression, which was our model. I will train it on this of the train and that of the S train and that of the Y train, and then we predicted on that of our S data to actually see how we're predicted on that. I got the output. We're able to actually give it our custom data that we can actually predict. Or actually have a table that has those of the data you want to actually predict. Make sure any data you are giving it must be of only 2 features, because for the training we only used make of 2 features and error. And everything we did here was just this was actually to get the threshold. So you can actually set the threshold. You can see that here it predicted 0 with the threshold of almost 0. Because the way it does, the one that has the highest threshold, the highest accuracy, that is the one is going to give you that's one that's going to be predicted. As we will have more data, most of the time you can see that it will be tending to maybe 0.4, the other one maybe 0.5 something, and maybe 0.6. So but since our data is really a little bit small, so that's why we're having this kind of result. I can see that our model is actually suffering from that of the underfitting. From the look of it, actually the data is actually small. It's suffering from that of the underfitting. So we're still based this. We're still going to do for a whole lot of that of the. I try to evaluate our models. Say in case if you want to get actually how well does it perform, what is the accuracy score, what is the classification score, what is the confusion matrix, recall, precision. If you are interested, especially that of the accuracy, how accurate is this of our model? These are things we'll be looking at in our next video. So I'll be happy to see in that of the next video. Thank you for watching this video.